Hello everyone! In this lesson, we will learn the basic concepts of motion control and the motion control configuration of a rotary feeding tree. First, let's start with the basic concepts of motion control. We'll begin by looking at the definition and the components of motion control. Motion control refers to the technology that uses computers or other electronic devices to precisely control the position and the speed of mechanical devices. In the automation area, the main objects of motion control include servo motors, stepper motors, and other equipment on production lines. Motion control technology enables these devices to move, stop, accelerate, or decelerate in a predefined manner to achieve precise positioning and operation. Next, please answer this question. What type of device is primarily used in motion control to precisely control the position and speed of mechanical devices? A. Sensors. B. Computers or other electronic devices. C. Motors. D. Hydraulic cylinders. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's keep going. A motion control system generally consists of the following 3 main parts. Controller. This is the brain of the motion control system, usually a programmable logic controller or other dedicated motion controllers. The controller processes motion commands and feedback signals and executes control algorithms to ensure accurate motion execution. Drive and actuator. These are the mechanical parts that perform the actual physical motion. The driver receives signals from the controller and converts them into mechanical motion. The actuator is the mechanism that produces the motion, such as motors, hydraulic cylinders, pneumatic cylinders, etc. Sensors and feedback system. Sensors are used to monitor the state of the system in real time, such as position, speed, acceleration, etc., and feed this information back to the controller. This enables the system to achieve closed-loop control, ensuring that the actuator's actions match the preset parameters. The commonly used motion control sensor is the encoder. Next, please answer this question. In a motion control system, which part is responsible for processing motion commands and feedback signals and executing control algorithms? A. Driver. B. Sensor. C. Controller. D. Actuator. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Next, we will learn about the motion control configuration of the rotary feeding tree. This time, the motion control object we use is the rotary feeding tree, as shown in the figure. The rotary feeding model is used to simulate material supply equipment in a production site. It has 6 material storage positions. An industrial robot can place materials on it or remove materials from it according to actual production needs. The positions which the industrial robot assesses materials are fixed, which requires the rotary feeding device itself to be rotatable. The power source for rotating the rotary feeding device is the stepper motor below it. Next, please answer this question. In the motion control of the rotary feeding tree, which device is the power source for rotating the feeding device? A. Industrial robot. B. PLC controller. C. Stepper motor. D. Encoder. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's continue. So, how do we make the stepper motor rotate? First, we need a driver for the stepper motor, as shown in the figure. This driver amplifies the low power pulses from the controller into high power pulses to drive the stepper motor. The controller here can be a PLC, a microcontroller, or other devices capable of continuous sending pulses. The terminals on the stepper motor driver that receive signals from the controller are the enable signal port, the direction control port, the pulse input port. We've learned about the stepper motor and its driver. If the controller is a PLC, the wiring method for the PLC to control the stepper motor is shown in the following figure. In this case, the Siemens PLC controller's Q0.0 sends the stepping pulses to the stepper motor driver of the rotary feeding model. Q0.1 sends the direction signal, and the origin point of the rotary feeding tree is I1.0 as shown in the table. Next, please answer this question. In the case of the Siemens PLC controlling the stepper motor of a rotary feeding tree, which output port is used to send the stepping pulse signal? A. I1.0, B. Q0.0, C. Q0.1, D. %I1.0. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Let's look at the question below. When configuring the motion control parameters for the rotary feeding tree, if the stepper motor shaft rotates 80 times for every 1 rotation of the reducer's output shaft, how many degrees does the rotary material tree rotate when the stepper motor shaft rotates 360 degrees? A. 1 degree, B. 4.5 degrees, C. 80 degrees, D. 360 degrees. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's continue. After completing the hardware wiring, we also need to perform software configuration. The motion control function for the shaft can be achieved through the object configuration process of the Siemens PLC and the necessary motion control instructions. The configuration process is as follows. Add a new process object. The process is shown in the figure. Change the measurement unit since the rotary tree performs circular motion. The position unit here is selected as degrees. Driver settings. In this case, the control method for the shaft is pulse plus direction. The pulse output signal uses Q 0.0 and the direction output signal uses Q 0.1. Mechanical parameters settings in the extended parameter. The number of pulses per motor revolution is set to 6400, which means for each 4 rotation of the stepper motor shaft, the PLC needs to send 6400 pulse signals. The load displacement per motor revolution is set to 4.5. In this case, the stepper motor shaft is not directly connected to the rotary material tree, but through a reducer as an intermediate link. That is, when the stepper motor shaft rotates, it drives the reducer, and the reducer shaft when drives the rotary material tree. The reduction ratio between the stepper motor and the reducer is 80:1, meaning the reducer's output shaft rotates once for every 80 rotations of the stepper motor shaft. Therefore, we can calculate the following relationships. When the stepper motor shaft rotates 360 degrees, the rotary material tree rotates 4.4 degrees. Motion parameters settings. The settings for parameters such as the unit of speed limit, maximum rotational speed, start-stop speed, acceleration, deceleration, deceleration time, etc. As shown in the figure. Emergency stop setting. The shorter the emergency stop deceleration time is set, the faster the motor shaft will stop when the emergency stop button is pressed in an emergency. Homing. The home switch corresponds to I1.0. Select high level active. Choose high level if the sensor is normally open, and low level if the sensor is normally closed. For the approach homing direction, select positive direction. Select lower side for the reference switch side. Set the approach speed to 15 and homing speed to 10. The approach speed should be higher than the homing speed. The offset of the home position is the distance to offset after finding the home switch to set that position at 0. After setting the above parameters, we need to perform manual debugging first. The debugging process is shown in the practical operation video.
Alright, after we have finished the configuration, click Debug, double-click it. And then we click Activate. Click Yes here. And click Start here. First, let's take a look here. There are 3 options: jog, position, and home. Let's select jog first. The speed option can be adjusted here, and acceleration and deceleration can also be adjusted. We click forward rotation first, and found that the rotary tree starts to rotate. Then we click on backward and found that the rotary tree starts to rotate. We can increase the speed a little bit and then click forward. Alright, then click backward. Okay, next, let's click position. For example, if we position it to 60 degrees, then click relative. Now we can see that the position is 60.42 with a little deviation. Next, we select Home. Click Home to see how the position here is changing. We can see that when this iron block touches the home position, it returns to the origin. Let's look at the reference point position here. The current position is 0.
Everyone, in this lesson, we learned the fundamentals of machine control, covering controllers, actuators, drivers, and feedback systems. We focused on the motion control configuration of the rotary feeding tree, including PLC wiring, software configuration, and debugging. That will lay the foundation for subsequent practical operations. For specific practical applications, please continue to watch the practical operation videos of the relevant sections in this chapter. That's all for this lesson. Thank you for watching.